The next function is part B. Q of x is equal to negative 3 to the x. So if you look at this, we have 3 to the x, which is the parent function, and all we've done is stick a negative out front. So if you remember, think back to your transformation rules. If you take your parent function and you just stick a negative out front, that is a reflection about the x-axis. Okay, I'm going to try to do this one in purple. Hopefully, well, I'm not really sure if that's a clear difference between the blue and the purple. But this is going to be a reflection about the x-axis. Okay, so we're going back to the parent function, which is the blue graph. Okay, and we are going to reflect it about the x-axis. So all you do is imagine taking your sheet of paper and folding it over the x-axis. So the graph is going to come down into quadrants 3 and 4. So remember what I told you when we were graphing the red function. When you're doing a transformation of an exponential, you really want to consider where the asymptote is going to go first. Okay, so remember, we're starting with our parent function, which is the blue graph. The horizontal asymptote for the blue graph is the x-axis. If you take your sheet of paper and you fold it along the x-axis and you're going to send the parent function into the third and fourth quadrant, your asymptote does not move. It is going to have the same asymptote, the x-axis, as the parent function. Okay, so the asymptote won't change here. All right, so we're going to go ahead and take each point on the blue graph and we're going to flip it over the x-axis. Okay, so remember, I'll start here. This point 0, 1 is 1 unit above the x-axis. So when you fold a sheet of paper, it's going to go 1 unit below. Okay, and then your next point is, let's see, this is 1, 3. It's 3 units above the x-axis. So when you fold the sheet of paper, it's going to go 3 units below. So it's going to go to 1, negative 3. And then, let's see, we got one more point here on this side. This is 2, 9. Okay, it's 9 units above the x-axis. So when you fold the sheet of paper, it's going to go 9 units below. So it's going to get sent to 2, negative 9. Okay, so remember, when you're doing an x-axis reflection, all you have to do is keep the x-coordinate the same and you change the y-coordinate. That's another way you can look at this. Okay, these little guys over here, the decimals. Okay, so remember, you're going to flip from 1/3 above to 1/3 below, and then 1/9 above to 1/9 below. Okay, so just kind of estimate those. All right, this guy, like I said, is 0, negative 1. All right, so you're going to draw, connect the dots. You're going to have the same basic shape, but since we've flipped it over the x-axis, instead of climbing quickly, we're going to be decreasing quickly. Okay, and then this side again will level off closer and closer. It'll get closer and closer to the x-axis because it's going to have that as an asymptote as well. Okay, and so that is your graph of negative 3 to the x. All right, now that we have that, we're going to write down our attributes. Okay, first thing we need is the domain. The leftmost point is, of course, going to be negative infinity. Okay, the rightmost point in the x direction, remember, this is going to go down, 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 but that's going to be corresponding to these x values. So the domain's going to be all real numbers. It's still an exponential function. All right, the range, you want to go from bottom to top and write down y values. Okay, your lowest point on the graph is definitely negative infinity. Your high point, your values are getting closer and closer and closer to the x-axis, but you never touch or cross the x-axis, okay? So you're getting closer from this side. So your y values are like negative 0.1, negative 0.01, negative 0.00001, okay? But at the end of the day, you're getting closer and closer to the x-axis, which has an a y coordinate of 0, okay? So we're going to go ahead and say that the highest y value is going to be 0, which is at the x-axis. Okay, we never reach it, so we're just going to put a parenthesis there. Okay, so that's the range for this one. And we know that for this particular graph, the horizontal asymptote is the x-axis. Okay, and so that is going to be the equation y equals 0. Okay, every point on the x-axis has a y coordinate of 0. Okay, so that's how you do part B. All right, so let's jump to part C, which is the last transformation. We're going to try to stick it, this graph is getting pretty congested, but we'll go ahead and try to put it on the same grid. I'll put this one in green. Not really sure what color it's going to show up for you. You still have a negative sign, but now the negative is in the exponent instead of being out front, okay? So this is going to be another reflection. Anytime you have a negative sign involved, it is a reflection. So again, think of the exponent as parentheses. Whatever is in that exponent is trapped, just as if parentheses traps things, okay? So anytime you had a negative inside the parentheses, that meant it was a reflection about the y-axis. So that's what this is going to be. So let's go ahead and graph that, okay? We're going to go back to the parent function, the blue guy, and you're just going to take each point and reflect it about the y-axis, okay? So remember, when you do a y-axis reflection, the y-coordinate stays the same and you change the sign of the x-coordinate. All right, so I'm going to start with the blue graph, but again, before I do that, let me check really quick what's going to happen to my asymptote, because you need to think about that. If you're just doing a reflection about the y-axis, so like if I had this part of the blue graph and I flipped it over here, this part's going to go to quadrant 2, and then if I had this little portion, it's in quadrant 2, it's going to flip to quadrant 1. Your horizontal asymptote is not going to change. It's still going to be the x-axis, so that's not going to move. We just need to worry about the points, okay? All right, I will start here at 0, 1, okay? It is on the y-axis, so it's going to stay put, okay? This guy at 1, 3, it's 1 unit to the right, so it's going to flip and go 1 unit to the left. So it's going to go to negative 1, 3. This guy at 2, 9 is 2 units to the right of the y-axis, so it's going to flip and go 2 units to the left. So it's going to go to negative 2, 9. And then these guys, the little smidgens over here, okay, this is negative 1, 1/3. So it's going to flip to 1, 1/3. And this guy is going to flip from negative 2, 1/9 to positive 2, 1/9. Okay, so those are going to be your points. This side is doing this. This side is doing this, getting closer and closer to the x-axis, but never touching it. So you end up with this decreasing function here. Okay, all right, so this is the graph of 3 to the negative x. That's what it looks like. Okay, and again, the specific points are negative 2, 9, negative 1, 3, 0, 1, 1, 1/3, and 2, 1/9. Okay, so let's go ahead and write down attributes. Okay, still an exponential function, so the domain is all real numbers. And our range, we want to go from the low point to the high point, but write down y values, okay? Our lowest point on the graph, we're getting closer and closer to the x-axis without touching or crossing it. So anything on the x-axis has a y-coordinate of 0. So since we never touch it or cross it, we're going to exclude 0. And then our highest y value, our points keep going up, 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 so our highest y value will be positive infinity. And then the horizontal asymptote is again the x-axis, okay? And just like over here, that is the equation y equals 0. All right, so there's your graph and its attributes.